Hello friends, and welcome to the basic course of engineering circuit analysis. So in this video, we will start our discussion on some very basic terms which you have to understand for networks and circuits, which are nodes, paths, loops and branches. Now these are very basic terms, and the importance of these terms is that when you go to understand circuits, these type of terms will continuously come in the literature. Now in this course, actually there is one idea or one philosophy that usually we are following, which is called a lumped circuit abstraction. The idea of lumped circuit abstraction is that you take the entire property. For example, in a resistance, for a resistor, the resistance is the property. You take the entire property and you lump it into a single point. Lump it into a single point. Or we can also tell that we concentrate the entire property. Okay, for example, in a resistor, it is resistance. Let me give you a formal definition for resistance as well. Of course, we will be dealing with resistance when we look into the concept of Ohm's law. Now, basically, resistance, the concept of resistance or the definition of resistance is actually the ability of a material, to oppose the flow of current, So that is the basic idea of resistance, flow of current. Okay, so these are the properties of general conductors, and the unit of resistance is called ohms. So it is written like this. This is the symbol. Of course, I have already told you that we will be discussing the concept of resistance in much detail when we deal with the Ohm's law. This resistance is only to understand what I am going to tell now. Now, for example, in case of resistance, in engineering circuit analysis that we are going to discuss, the entire resistance in this case is concentrated at a single point. That is why when usually we draw circuits, we represent it like this. So the entire property of the resistance of that particular conductor or the elements which are connected to that conductor is concentrated at this particular point. When I develop this circuit, you can see that I'm just drawing things like this. So this represents the entire resistance associated with this particular conductor. But however, in advanced courses like say power systems, a distributed network is used. So in this case, for example, in this circuit, I will tell that the resistance is 2 ohms. I will say the resistance is 3 ohms. I will tell the resistance is say 5 ohms. But in advanced courses like power systems, when you are dealing with conductors which are very, very long, kilometers and kilometers, in that case, you say the resistance is spread throughout the length of the wire. So for a conductor which is used in power systems, you say the resistance is say ohms per kilometer. So depending upon the kilometer drawn by the conductor or the length of the conductor, you can find the total resistance of the circuit there. So that is the basic idea. So whenever we use in engineering circuit analysis in this course, understand that we are using something which is called the lumped circuit abstraction. Therefore, whenever you see the course, you will see that the circuits are drawn like this. Okay, so this is a property of resistance, this is the property of resistance. But this is not only for resistance, even for capacitance. For a capacitive circuit, we might draw like this. So the entire property of capacitance is in this particular point. Similarly, for inductance, you might draw something like this. So the entire property of the inductance is brought in this particular point. Similarly, in capacitance, inductance also, you have capacitance, farads per kilometer, ohms per kilometer, etc. in power systems. Now, let us move into the definition. The first definition is which is called the node. Okay, first definition is for a property which is called node. So what is a node? The node is a point at which 2 or more circuit elements have a common connection. Okay, so node is a point at which 2 or more circuit elements have a common connection. So let's draw 2 circuit elements here. So this is one circuit element and this is the second circuit element. Okay, the definition has 2 or more. So I'm just drawing 2 here. So in this case, if you see this point here, this point is a common connection between these 2 elements. So this is a node. Right, this is a node. Let me call it as N1. I can draw another circuit here. So let me draw another circuit. Okay, so I have 3 elements here, and in this case, if you see, this is also a node where 3 elements are connected. This I can call it as node N2. So if you see this circuit, how many circuit elements are there? You are having 1, 2, 3, 4 and 5. So in this case, if you want to find the number of nodes here, you just have to see the common points. If you see this point here, this point, here all the circuit elements are connecting together, right? So I will just call this as node 1. So let us see what all circuit elements are connected to this common point. So let me call this as I1. So I1 is connected here, I1, R1, R2 and R3. So in the node N1, you can see I1, R1, R2 and R3 are connected. Similarly, if you see the bottom position here, there are also so many circuit elements are connected. So this is also a node because 2 or more circuit elements are getting connected at this point. So let me call it as node 3. Okay. So in this node, I1, R1, R2 and R4 are connected, right? I1, R1, R2 and R4 are connected. Now the definition is, it is a point at which 2 or more circuit elements have a common connection. So if you look at this point here, if you look at this point, here R3 and R4 are common connected in this point. So this is also a node. I can call it as node 2 in which R3 and R4 are connected. So I hope the definition of node is clear. Now let's move to the next definition, which is called a path. Okay. So what is the basic idea in general for a path? If you see the English language, the basic idea of path is the course or direction. The course or direction. The course or direction in which a person or object is moving. So path is basically a route in which a person or object is moving. Similarly, in engineering circuit analysis also, a path is a set of nodes. The path is a set of nodes where nodes or circuit elements. The path is a set of nodes, circuit elements we pass through while moving along a particular circuit. Okay, so we can define multiple paths for a particular circuit. For example, let me define path 1. Okay, so let me first mark the nodes which we have marked already. So this is N1. Okay, so this is N2 and this is N3. Okay, so let me define one node here, one path here. Let me call that path as path 1. Okay, so I'm defining the path 1, which is a set of nodes and circuit elements that we pass through while moving along a circuit. Okay, so I'm going to take this path where I'm going to cross N1, R3, N2, R4 and N3. Okay, so I'm going to take this particular path here like this. So I'll just draw it for 1 in dotted lines. But if you continuously have the habit of doing dotted lines, your circuit diagram will get very cluttered. Okay, so I'll just draw it for 1. So I'll take the path. The path is N1, R3, N2, R4 and N3. Right. So when I write something like this, it means that I'm moving from N1, R3, N2, R4 and N3. So this is the path that I'm taking. I can define another path also. So like P2 is equal to, I'm moving from N1, R2, N3. Okay, so in this case, I'm moving from N1, then I'm going to R2, and I'm going to N3. Okay, so I'm not doing the dotted lines here because you should not have a habit of doing a lot of things in your circuit because the circuit diagram will get very cluttered. So just understand this is the path N1, R2 and N3. So this is a path 2. I can define another path. This is a set of nodes and circuit elements that we pass through. Okay, so maybe I can take N1, R1 and N3. Okay, so in this case I'm moving from N1, R1 and N3. Okay, N1, R1 and N3. And this is I1 here. So I can define another path, say path 4. That can be N1, I1 and N3. Okay, so N1, I1 and N3. So this is another path here. Okay, now just like when we defined for networks, okay, whenever you have a network which is having a closed path, you call it as a circuit. Similarly, when you are taking a path and it reaches the original node in which you started, it is called a loop. Okay, so let us just see that here. So the loop definition is, if we reach the same node that we started with, then that path is called a loop. Now if you look the previous diagram here, for example, let's take the path 1. So we are starting from N1, R3, N2, R4 and N3. We have not reached back N1. So this is the path that I have taken. I have traveled from N1 to N3 through R3, N2 and R4. Okay, so I have not reached the original node which is N1. But however, if you move to that original node, you call that path as a loop. Okay, so that is the definition of loop. So I think we can define some loops here. Let me just see. So let me just take L1. I will first define L1 and then we can let me just mark the node also. This is N1, this is N2, and this is your N3. Okay, so let's take the first loop here. So the first loop I want to take is N1, R3, N2, R4, N3. Okay, and then I'm going for I1. I will go through I1 and I'm coming back to N1. So I've started from N1 and I've come back to N1. So that is the first loop that I'm doing. That is called a loop. So let's write that down. So N1, R3, N2, R4, N3, I1, and I'm coming back to N1. So since I have come back to N1, it is called a loop. If I had not come back to N1, it would have been called a path. Okay, so let's write another example for a loop. So these are very important. That's why I'm taking enough time to explain this. Once you understand that, it's going to be very easy. So the next path I'm going to take is N1, R3, N2, R4, N3, R2, and N1. So let us just see in the diagram where is that path. So I'm starting at N1, going to R3, then through R2, then R4, then I'm going back to N3. Okay, I'm going to N3, then I'm coming to R2, then I'm coming back to R4. So I've moved the path like this, and I've come back to N1. So this is the next path, next loop, sorry. So this is L3. I'm going to take the next loop here. That will be N1, R3. N1 in the sense it is node 1. R3, node 2, then R4, then N3, then R1, and I'm coming back at N1. Okay, so I've taken the path like this: N1, R3, N2, R4, N3, R1, and N1. Okay, now for the fourth loop, I can look at this particular configuration here. So I can define another loop here. So N1, R2, N3, and R1, and N1. Okay, so this is also a loop. So N1, R2, N3, R1, and N1. So this is also, I'm starting at N1 and I'm coming back at N1. So that is why it is called a loop. Then let me write another loop. N1, R1, N3, and I1, and I'm coming back at N1. So which is this loop? Okay, so it is N1, R1, N3. I'm going to I1 and then I'm coming back to N1. So this is also a particular loop here. And finally, let us just conclude this by doing one more loop. So that will be N1, R2, N3, I1, and N1. Okay, so in this case, I am going through R2. So N1, R2, N3, I1, and N1. So initially I had taken this path here like this. That is a loop. So second path is also a loop which I am moving like this. Okay, so I hope you understood the definition of loop very clearly. Let's move to the next topic now. The next topic is something which is called a branch. The branch, it is a simple path that has a circuit element with two nodes at each end. So that is the definition of a branch. Okay, so it is a simple path that has a circuit element with two nodes at each end. Now, if you take a circuit element like this, okay, it has 2 points here. So the idea is that when you are having a path in which you are having two nodes at each end, that is called a branch. Now, if you look at this particular circuit, that will be very clear. So this is N1, this is N2, and this is N3. Okay, so if you see in this case, let us take one path 1. I'll take a path. I'll take N1, I1, and N3. So N1, the set of N1, I1, and N3. Okay, this is the path I have taken. We see this path, it perfectly fits the definition of a branch. It is a simple path, okay, which has a circuit element and has two nodes, right? So I1 has two nodes, N1 and N3. So that is the path 1. Okay, so this path can also be called as a branch. Okay, so when a circuit element has two nodes around it, it is called a branch. Okay, that path is called a branch. So let's take the next path, P2. Another path I am taking, N1, R1, and N3. Okay, so that is this path. This is the path that I have taken. Remember, the definition of the path is a set of nodes and circuit elements that you are crossing when you are moving in a direction of the circuit, in a particular direction of the circuit. So this is also a branch, you can see, right? It has one circuit element and it has two nodes. So this is also a branch. Okay, I'll write it as B1. This I'll write it as B2. Let me write another branch here. Okay, so this N1, R2 and N3. N1, R2 and N3. Okay, so this also has a circuit element and has two branches, right? Two nodes here. So it is also a branch. Let me bring the fourth branch here. If you see here, if I take a path like this, that is N1 and R3 and N3. Okay, so I'm moving from here to here like this through R3. This is also a branch because it has a circuit element and it has two nodes. So this is also a branch, B5 and B4. And finally, I'm going to take another path, which is, let me mark this as N2. Okay, this is actually N2, right? So I'll just correct it here. So this was N2. Sorry for that. This is actually N2. Let me take another path from N2 to N3. Okay, so N2, R4 and N3. So you can see it also has a circuit element and has two nodes. So this is also a branch. So if you see, the total number of branches that I can construct in this circuit is actually 5. The total number of branches that I have constructed in the circuit is 5. And if you notice another thing, the total number of circuit elements, 1, 2, 3, 4 and 5. The total number of circuit elements in this circuit is also 5. Okay, so based on this particular definition, it is a simple common sense that the number of branches in the circuit will be the number of circuit elements of the circuit. So if somebody asks you how many branches are there in a circuit, you can easily find, if it's a simple circuit like this, by counting the number of circuit elements. So I hope things are clear. Now, there is a simple definition for finding the number of branches as well. So the number of branches is equal to the number of independent loops L plus the number of nodes minus 1. Okay, this is an important relation which you can remember. So the number of branches is equal to L is the number of independent loops, number of independent loops. L is the number of independent loops and N is the number of nodes. Okay, minus 1, you will get the total number of branches. Okay, so this is a definition of branch, and I think we can conclude today's video with this. And the next video we will do a few numericals to understand all these concepts in a much better fashion. Thank you.